Okay, let's put it all together now and look at these practice problems. Number 1, the ages of residents of Bank City, Oregon are given in the following frequency distribution. You can see 283 people are in the age range 0 to 9, 203 people are between 10 and 19, etc. And our goal, based upon this grouped data, is to approximate the mean age. So what we need to do is we need to come up with an approximation of the sum of all ages and then divide by the total number of people. So how do we approximate the sum of all ages? Well, let's go look at each category individually and approximate people's ages in that category. So, these 283 people, we don't know what their ages are. Their ages could be on the low end, they could be on the high end. And so a safe number to take for each of these 283 people is the middle of this interval. So what is the middle of this interval? Well, a lot of you might think the middle of 0 and 9 is 4.5, but to be consistent with our textbook and connect, we're going to say that the middle of this interval is the average of 0 and 10. So we'll say that the middle of this interval is actually 5. In which case, the sum of all of the ages for everybody in this particular category would be 5 times 283. Let's do the same thing for all of these categories. And so we'll identify the middle of the category and then take the product of the middle of the category and the frequency number. So the middle of this category will be 15 and then 25. Remember, I'm taking the average of the lower class limit and then the next lower class limit. The middle of this category will be 35, 45, 55, 65, 75, 85, and then the last one would be 95. And so the sum of all of the ages for the people in each category will be the product of this middle number and this frequency here. This is our approximation of the sum of all of the ages in each category. So we'll have 15 times 203, 25 times 217, 35 times 256, 45 times 176, 55 times 92, 65 times 21, 75 times 23, 85 times 12, and the last one, 95 times 3. So let's punch this into the calculator, and we're going to try to get the sum of all of these. And that's going to be the approximate sum of all of the ages for all of the people that we have in here. And so we'll say 5 times 283 plus 15 times 203 plus 25 times 217 plus 35 times 256 plus 45 times 176 plus 55 times 92 plus 65 times 21 plus 75 times 23 plus 85 times 12, and the last one plus 95 times 3. And we get a grand total of 36,220. Now, if that's going to be our numerator, then we need to divide that by the total number of people that we're dealing with here. And the total number of people that we're dealing with is the sum of the frequency column. And so separately, let's go into the calculator and do 283 plus 203 plus 217 plus 256 plus 176 plus 92 plus 21 plus 23 plus 12 and then plus 3. And we get a grand total of 1,286 people. And so our solution to this question will be 36,220. That is our approximate sum of all of the ages of all of the people here. And we are dividing that grand total by the total number of people of 1,286. So if I say 36,220 divided by my answer, my previous answer, I end up getting a mean age of 28.2 years. So my answer is 28.2 for question 1. Okay, let's go on to question 2. This one says, find the population variance and standard deviation for the following population. And just to be clear, if it's saying find the population variance and standard deviation, they're saying find the population standard deviation and the population variance. So the population standard deviation is going to be sigma. And I'll denote this population standard deviation, and then the population variance is going to be sigma squared. And remember, the calculator is going to give us sigma. We'll have to square that result to get sigma squared. A lot of times, though, your homework is going to ask you for the variance first. So just because we are getting the standard deviation first from the calculator, don't, pay attention to the fact that you still may be asked for the variance first in your homework. So I've entered this data into list 1. I did stat edit, and you could see in list 1 I have 16, 6, 18, 3, 25, and 22. And the tool that I'm going to use here is stat calc, and it's 1var stats. So I'm going to go to this 1var stats tool, or 1 variable stats, press enter, and I need to indicate that I'm working with list 1. And so if you don't have this type of a setup in your calculator, then you should indicate to your calculator that it's list 1 by saying second number 1 and getting L1 immediately after that 1var stats. But if you have my setup, then you just go down, press calculate, and population standard deviation, sigma, is equal to, you can see it right here, it's equal to 8. And so that is our population standard deviation, and if we want the population variance, we just square that answer and get 64. Okay, let's take a look at question 3. Question 3 says, first of all, is the empirical rule okay? Can we apply the empirical rule in this context? The following histogram presents a data set with a mean of 16 and a standard deviation of 2. Is it appropriate to use the rule to approximate the proportion of the data between 12 and 20? If so, find the approximation. If not, explain why not. So when I look at the shape of this distribution, it does have that approximate bell shape. So I think we're safe to say that the empirical rule will apply here. And when it does apply in a situation, I suggest getting all 3 pieces of information that it gives us. So it gives us an interval where 68% of our data is going to be, where 95% of our data will be, and then an interval in which 99.7% of our data is going to be. And so let's start at our mean, which is at 16, and let's just deviate 1 standard deviation on both sides. Now, 1 standard deviation is equal to 2. So if I deviate 2 on both sides, then that's giving me an interval of 14 to 18. So 68% of my data will be between 14 and 18. If I start at the mean and I deviate 2 standard deviations, then that means I'm deviating 4 on both sides of 16, because 1 standard deviation is 2, so 2 standard deviations would be 4. And if we deviate 4 on both sides of the mean, then we get an interval going from 12 and going all the way up to 20. So we get the interval 12 to 20. And then if we started at the mean of 16 and we deviated 3 standard deviations, then we'd be going all the way up to 22, and then we'd be going all the way down to 10. So we get that interval of 10 to 22. So to answer our question, what proportion of data is between 12 and 20? Well, we can clearly see that it's 95%. Okay, one more example here. We've got number 4. The table below presents the 2008 payrolls in millions of dollars for each of the 30 Major League Baseball teams. So we need to construct the 5-number summary, find the IQR, find the upper and lower outlier boundaries, and then decide if we have any outliers in this data. So the first thing that you should do in a question like this is enter your data into a list in the calculator. And so I've done that. If you press Stat Edit, You can do that in your calculator, but you could see that I've entered all of this data in list 2. To get the 5-number summary, we saw that we can go back to this one variable stats tool again. And so if I press stat calc one variable stats, my data is now in list 2, so I need to change that. Just make sure that whatever list your data is in is the list that you have here. And you press calculate. And the 5-number summary is what we get if we scroll down to the bottom. And the 5-number summary includes the min, Q1, the median, Q3, and the max. So I'm just going to list this out. Our 5-number summary is 22, 66, 80, 119, and 209. Okay, find the IQR. Now the IQR is the interquartile range, and that is Q3 minus Q1. Remember, this is Q1 right here, and this is Q3. So Q3 minus Q1 is just going to be 119 minus 66. And if we go into the calculator and just do that real quickly, 119 minus 66 gives us just 66, gives us 53. This interquartile range is important for setting up these upper and lower boundary formulas. So our lower formula is going to be Q1, which is 66, minus 1.5 times that IQR, so minus 1.5 times 53. And then the upper boundary is going to be Q3, which is 119, plus 1.5 again times that IQR. So let's punch these into the calculator and see what boundaries we get. So 66 minus 1.5 times 53 gives us negative 13.5. And then on the upper end, 119 plus 1.5 times 53 gives us 198.5. And so, do we have any data points that are lower than our lower boundary or higher than the upper boundary? And I think the only data point that is outside of one of those boundaries is this one. And so it seems like the New York Yankees are always outliers, and once again, according to the 2008 payroll, they are. So the only outlier that we have here is 209. Now remember, you can visualize a lot of the material that we just covered in this example in a box plot. And so if we press second y equals, and we make sure that we have a box plot selected, and it's always the box plot with outliers, we might be able to visualize the same type of stuff that we just came up with. The one big thing that I have to change here is the X list. My X list should be L2 because I entered the payroll data into list 2. And then we would press zoom number 9. And if I press the trace button, you've got the min of 22. That's what we saw as part of the 5-number summary. We arrow over. That first part of the box part of the box plot is 66. As you can see here, Q1 is 66. We arrow over again. The median is 80. We arrow over again. Q3 is 119. And then you arrow over again and we get 139. Now that is not our largest value. That is the largest value before we have any outliers. And then you can see if you arrow over again, we've got that outlier of 209 acknowledged in this box plot. So it's really nice to know that the same formulas that you're using here, your calculator is using to determine outliers. So now that you've seen these practice problems, I suggest digging right into that homework. Good luck.